So we're going to solve this problem, graph the function f using transformations, the techniques of shifting, compressing, stretching, or reflecting. F of x equals negative 2 multiplied by x squared minus 4x plus 1. We know this is a quadratic equation. It's a specific kind of polynomial. The first thing we want to do here is to complete the square. So first step in doing this is to complete the square. And we do that so that we get our equation in the form of f of x equal a times x minus h plus k. And from this form, we can determine that the basic function, I'm sorry, this is squared, the basic function, which is the first thing we're going to graph, and in this case we already know, because it's a square there, that our basic function is going to be y equals x squared, and we'll graph that first. Then the next thing we'll do is to determine from A the stretching, compressing, and or reflecting. And we're going to do that the first step after our basic function, and then we're going to shift it. Stretching, compressing, or it could be and I think I just went off the thing, and or reflecting. If it's negative, we know that it reflects across the x-axis. So then the fourth thing we're going to find is h, which is going to give us our horizontal shift. And then k, which is going to give us finally our vertical shift. And we always try to spell correctly. Okay, so those are the steps we're going to follow once we get our function into the correct form. So again, our function is f of x equal negative 2x squared minus 4x plus 1. And our first step is to complete the square. So, whoops. So completing the square. To do that, we write the function f of x equal, we look at the first two, the x squared and the x, and we factor out our a. So negative 2 will come out of there, and we end up with x squared minus 2x. Now I don't have that right, do I? Because it was minus 4x. So when I factor out a negative 2, this becomes positive 2x. And we're going to just move that plus 1 over, and we're going to complete the square. To complete the square, we look at the second term here, the b, and we take half of that. Half of 2 is 1, and 1 squared is 1. Now to keep this even, we want to make sure we subtract off what we have added, and we have to be a little careful here because it looks like we added a 1, but we really didn't just add a 1, because this is a negative 2 out here, and we're going to multiply that negative 2 by that 1. So we have a negative 2 times 1. We have added actually already a negative 2. And so to get rid of that, we want to add a positive 2. Negative 2 times 1, that's negative 2, and to add that we're adding a positive 2, so everything has stayed even. We have to be careful because that is inside the parenthesis, and the distributive principle tells us that that negative 2 will multiply by that. So now we have our square in here. This is x plus 1, the quantity squared, and then plus 3. So from this we know that a equals negative 2. We know that we will be stretching and as well as reflecting about that x-axis. We know that h equals -1. That means we're going to have a horizontal shift of -1. Here, I'll write this. Remembering up here that the form we're trying to get this into is f of x equal a times x minus h, the quantity squared, plus k. So because this is a positive, we know that h is a -1, meaning we're having a horizontal shift to the left, and then k is a +3, so we know we're going to have a vertical shift of 3 up. We also know that our vertex is going to be -1, 3, because the vertex is at hk. And so we can check at the end, and hopefully we end up with a vertex at -1, 3. So again, we start with our basic function. We have our x and our y axis, and our basic function is y equals x squared. We know that that has a vertex at 0, and we know that it goes through -1, 1, and +1, 1. And we connect our dots, and we draw our y equals x squared. Okay, so the second step we're going to do is this reflecting it, and we're always going to do this next. Otherwise, we're going to end up, we can end up with problems and not in the right place. So I'm going to draw my x and y axis again. This is x, this is y, and now we're going to multiply by a -2. Oops, we've got to remember to label our points. I said them, but I did not label them. Okay, so the vertex will stay at 0, 0, even though we have a equals -2, and this and the function that we are graphing here is y equals -2x squared. So our vertex stays at the same place. I'll try to actually get it to go through the vertex. Our vertex stays at 0, 0, but our 1, 1, we go from, when x is 1, now y is going to be -2, and when x is -2, y will be -2. So now this point is 1, -2, and this point is -1, -2. And you can check that. If x is 1, I put 1 in here. 1 squared is 1 times -1 is -2. Okay, we connect our dots, and this one stays 0, 0. We want to make sure we keep labeling our main points. All right, and now the third step here is to do our horizontal translation. And in this case, we're going to shift 1 to the left. So instead of my vertex being at 0, 0, it's going to be at -1, 0. And then instead of being at 1, -2, it's going to shift 1 this way. So it's going to be at 0, -2. And this one, instead of being at -1, -2, is going to shift over and be here at -2, -2. I'm going to erase this so that we keep this all in one place. This one again is -1, -2. That's this point. And this now we have our third step, our horizontal translation, and our shift to the left. and this is y equals negative 2 times the quantity x plus 1 squared. And our 3 points, this one now is 0, negative 2, and this one is negative 2, negative 2. There are our 3 points, and our last step, unfortunately, isn't going to be in the videotaping range. I wonder if I can move my videotaping range over. Move this, short it a little. Okay, so then the last step is to do our vertical shift, and we're going to go up 3. So again, I'm going to truncate that one side of our graph. So we have now, instead of negative 1, 0, we're going to be at negative 1, but we're going to go up 3. 1, 2, here. And then instead of being at negative 2, negative 2, my x is still negative 2, but now I'm going to go up 1, 2, 3 points. So I'm going to be here. And here, instead of 0, negative 2, my x is still 0, but now 1, 2, 3 I'm at. And I can disconnect those. And I find that this point is negative 1, 3. This point here is negative 1, negative, or positive 1, negative 1, positive 1. And here, our last point, maybe I can put it in here, is 0, 1. Now, just a quick check, if you go back and think of the original equation we had, which is right here, if I put in 0 for x, I know that my intercept should be at 0, 1, my y-intercept here. And in this case, even though I'm off a little bit, my intercept is, in fact, at 0, 1. And this then would be y equal negative 2 times x plus 1, the quantity squared, plus 3. Again, we can just look at the things we know. A is negative 2, meaning that it'll open down. We open down. Our vertex should be at hk, which is negative 1, positive 3. It's at negative 1, positive 3. And we have our points labeled. Whoops, this is negative 2. We're at negative 2, positive 1, 0, 1, and negative 1, 3. So just keeping everything in check, we have our function graphed, and we have graphed the 4 stages. Always remember to do the A first, do the reflection and stretching and compressing before you move the vertex around. Do your shifting so that you always get it right. Anyway, that's it.